Hold on just a second.
The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and thank you for joining the webinar Using R with Hadoop. Presenting today is Jeffrey Breen, leader of Think Big Analytics Academy. And also joining us is Kathleen Rohrecker, Director of Marketing here at Revolution Analytics. Today's webinar will run about 15 minutes with 10 minutes of Q&A. The webinar is being recorded and will be available on our website within 48 hours. If you would like to ask a question during the webinar, please open the questions section of the control panel and type in your question and click send. We'll try and get through as many questions as we can at the end of the presentation, but as always, please feel free to contact us directly if your question wasn't answered. And without further ado, I'd like to turn the presentation over to our speaker. Jeffrey, please go ahead.
Yanni, thanks very much, and Kathleen, thank you very much again for having me. It's really exciting to be here, especially with such a large group who's joining us online. So I thought maybe we'd start out with a couple things you should know about me. First of all, I love data. So data itself, but working with data and really getting to the insights in data. So while I was a physics undergrad at Penn, I worked with a team to build a real-time collection and analysis system for EKG data, cardiac data, coming off of intensive care unit patients at the Children's Hospital of Philadelphia. So this was back in the late 80s, early 90s, back when chaos and nonlinear dynamics was all the rage. But despite the hype, we were able to make some meaningful contributions to the understanding of a certain class of cardiac arrhythmias. And that's really exciting. So I have a master's degree in astronomy. Actually, I have a bachelor's degree in astronomy also. I worked at the Harvard-Smithsonian Center for Astrophysics. I published in the Astrophysical Journal and even in Science. So I've been around data for a long time and really enjoy getting to the meaning of data. At the same time, I had a very long IT career. I left academia and joined the private sector right around the internet, right around the time of the internet, and have a very strong market research focus. Again, all around data, working with data and getting insight from data. So worked for some companies you may or may not have heard of. SNL Securities, now SNL Kagan, had some technology leadership positions at Forrester Research. I was the Chief Technology Officer of Yankee Group and worked with some startups also in the technology space and also in market research. Over my career, I've been a user and a buyer, or both, of most of the database systems out there, and nearly all of the analysis packages you can think of, you've ever heard of. Now I'm at Think Big Analytics, which is a professional services and consulting company built from the ground up just to work on big data problems. It's 3 years old, which is almost 3 years old, which is pretty old for a company dedicated to big data. Our CEO and co-founder, Ron Bodkin, has been using Hadoop in particular longer than most people had ever heard of Hadoop. He was the founding CTO at a company called Quantcast, which is still around and doing great, focusing on analytics around audience, web audience in particular. And he was using Hadoop in production before even Facebook was using Hadoop. We work with all levels in organizations and companies of all sizes, from the biggest in the world to the smallest startups that you haven't heard of, at least not yet. It's a really exciting place to be because we're the first place that many people call when they have an opportunity to take advantage of big data. We have a series of products. I don't want to turn this into a commercial, but I think it's helpful to understand that while we work on strategy in our envisioning product, we work with boards of directors and senior leadership. Our bread and butter is our engineering team, and we work on engagements with teams large and small, and even embed with some engineering teams working on product development in all fields, not just technology companies. My part of Think Big Analytics is the Academy. It's our training and education division. So I have two young daughters, and when they hear that I'm the principal of the Academy, I think immediately they think there's a little building with a flagpole out front. But that's obviously not true. But what I brought it up because it's really not true, because we don't have a separate team of trainers or educators. we rely on the most senior consultants in our organization to do all of our training and all of our teaching. And that helps us bring real-world experience to the classroom. And that's sort of shaped the way I wanted to I designed this talk. I really want to talk about a few scenarios where we've actually used these technologies, R and Hadoop, together in real client situations. So when I was designing this, I assumed that the audience was probably more familiar with R than they are with Hadoop. So I don't have a lot of introductory information about R, but quite a bit about Hadoop. And we go over sort of the MapReduce hello world, and we use the word count example. If you've seen this before, bear with me. Hopefully it won't be too long or tedious. And in all honesty, I didn't really understand it the first couple times I saw it either. So hopefully it'll be a useful review. As I'm thinking about how I've used R over the years, it's really become my Swiss Army knife for working with data. And when you hear Swiss Army knife, you may have sort of this picture evoked from childhood, where it's a trusty tool that you always have with you, and it's fairly simple, but it can do a lot of things. And while those things aren't untrue, when I think of Swiss Army knife in context of R, I'm really picturing something more like this. As I think about all the ways I've used R, in the last few years that I've been using it, whether just the variety of data types, flat files, relational databases, structured data, unstructured data, let alone all the amazing analysis and modeling tools that are just sort of built in there, or easy and free add-ons to R. It's really impressive to me. In fact, I got excited, so excited one day with how easy it was to pull in data from different sources. I did a little tutorial that's become sort of very, very popular about Twitter sentiment analysis. So some of you may have seen that tutorial. I know I'm not the only one who's excited about R. This is a slide I borrowed from my friend and colleague John Versatek from our meetup in town here in Boston, where I live. Just showing how many people, how many packages are being contributed to the community. It's really this amazing exponential growth. These are all packages that are available. People contribute a combination of code and data, and is really really impressive. So I thought maybe we could pause now. You heard a little bit about my background. I'd really like to hear from you.
Thank you, Jeffrey. So launch the first poll. What software do you currently use for predictive analytics?
So while our audience is answering that poll, on behalf of Revolution, I want to thank you, Think Big Analytics, and Jeffrey for presenting this webinar. As Jeffrey hinted, we had nearly 2,000 people register to hear this talk, which really reflects the tremendous interest in the market today in R and Hadoop. In the context of Hadoop Analytics, Jeffrey's going to be talking about Revolution R Enterprise, open source R, and some capabilities of Revolution's R Hadoop project that we developed and contributed back to the open source community, but that we support for Revolution clients. As we like to say, Revolution R Enterprise is 100% R and more. R is at the core of our platform, and we've added capabilities such as these R Hadoop capabilities and other capabilities within the Revolution R Enterprise platform that provide not just for Hadoop, but for other platforms as well, performance at scale, portability across platforms, and enterprise support, consulting, and training. So Hadoop is one of the very important platforms for us and our clients, and we've got relationships with the leading commercial distributors such as Cloudera, Hortonworks, and others. Think Big and Revolution Analytics are actively helping organizations take advantage of the power of R and Hadoop, and we've developed a quick start program that includes software services and training for organizations that want to better understand what Revolution and Hadoop can do for them. Jeffrey will provide a little more information about those offerings at the end of the program. So Yanni, I see the results of the poll. We do have a lot of R users on the line, R and Revolution users, Jeffrey, followed by SAS at 19%, SPSS 5%, Excel users 10%, and other 12%. So about half of our audience is familiar with R and Revolution, as you would have guessed.
Fantastic.
So Yeah, I just wanted to share a quick summary. When I mean by 100% Revolution is 100% R and more, we do keep everything that all of you know and love about R is embedded in the Revolution R Enterprise platform, but we've supplemented that with additional capabilities that bring it to production-grade enterprise deployments. Back to you, Jeffrey.
Great, thanks, Kathleen. Just have to advance. Here we go. So maybe we can sort of start talking about Hadoop and ask sort of the big question that's on your mind. You know, Hadoop is one of those words you hear a lot, and for many of us, our bosses have heard about, and it may be our job to get smart about it. So, you know, what is Hadoop? I think one of the myths out there is that it's you know, it's a thing. It exists as a package, as a product. You can just buy it, you've got it, and it's all set. Really, it's an open source project that encompasses you know, a few projects and a few components, but all of them are designed to support large-scale data processing. It's really inspired by the work that Google shared, the insight Google shared about how they solved some of their large-scale data processing problems using a programming paradigm called MapReduce. We'll actually do we'll go into MapReduce in a little more detail in a minute. But Hadoop itself is not just MapReduce, though it certainly has the processing framework and the job scheduler and processes to manage cluster resources, but it's also a Hadoop distributed file system. So if you think about what Google was doing, going out and trying to make a copy of the web, you know, every couple of days, sort of reminds me of the old joke, you know, why would you want everything in the world? Where would you keep it? Well, this was sort of Google's problem. They were trying to keep a copy of the internet and then do it every day or every couple of days. So you're just storing that amount of data and being able to access it are two different but very related problems. And Hadoop also has other components for, you know, bringing data into the system, bringing data out of the system from relational data sources. Programs like Scoop are available, from, you know, log files and other data sources. There's Flume and other systems out there. And then there's also higher level languages, some abstractions atop of the sort of the low-level MapReduce jobs and libraries that help. Languages like Hive and Pig, libraries like Cascading and Mahout. Hadoop itself is written in Java, and back in the old days, if you wanted to write MapReduce jobs, you had to write them in Java too. But really the first step to opening up Hadoop to other languages was the streaming API. And basically, if your language of choice can handle standard in and standard out, then you can use that language to write MapReduce jobs now through the streaming API. So with that bit of introduction, I'd like to hear from you folks to what extent you're actually familiar using Hadoop. Yanni?
Thank you, Jeffrey. So our second poll is, which of the following best describes your company's use of Hadoop?
So Jeffrey, what are you finding? Are people, what we're finding within the last 12 months, the market has really gone very quickly from experimentation to using Hadoop in production applications. You're finding the same thing?
Yeah, absolutely, Kathleen. So, you know, thinking about the engagements we've working on, you know, recently, it's not just you know, experimental you know, tiger teams in organizations anymore. It's not just startups. It's the biggest companies in the world who are looking to exploit this technology, and they're doing it, you know, not just for sort of one of the bad reps about open source is it's just about cost savings. It's not just about that. The projects we like to work on, the projects that get our data scientists excited about, is when we're working to find and to help exploit new opportunities, and that's important for businesses of every size.
Great, thank you, Jeffrey.
So the results are as follows, Jeffrey. So 3% are using Hadoop in production today with R-based analytics. 14% are using Hadoop in production with other analytics. 13% are testing Hadoop with R. 11% are testing Hadoop with something else. And almost 60% are planning but aren't yet doing anything with Hadoop.
Fantastic, fantastic. So it sounds like we have the whole range and
right.
a lot of people learning. So hopefully this will help. So I mentioned Hadoop streaming. I've got to click this, I think. So I mentioned Hadoop streaming and you know, the requirements to use it, and R certainly fits the bill. But in our Hadoop developer class, we have some streaming examples using Python and Ruby and some other languages. And one of the things that that always strikes me is how much overhead there can be when you're dealing with a relatively low-level I/O interface like standard in and standard out. And there's a lot of looping, a lot of bookkeeping, especially when you get to the reducer side. A lot of wild, standard in like looping. So I'm sort of admittedly lazy. And based on some work that Jonathan Seidman, who was then at Orbitz, did, he did a comparison of the various R libraries out there to work with Hadoop. And based on the code that he wrote and published, I picked RMR, which is part of the R Hadoop package. Is how I became familiar with R Hadoop, because it did more of that overhead for you. So honestly, this is how I got familiar with R Hadoop, and used it to great effect since. So what is R Hadoop? It's first and foremost, it's an open source project. It's sponsored by Revolution Analytics. It's on GitHub, and it's split into a few packages. So the bulwark of the functionality is in RMR2. That's where all the MapReduce related functions are. And there are all the support functions to help you write the code to write MapReduce jobs and to submit those jobs. And there are also a couple of support packages. RHDFS helps you work with the distributed file system. RHBase allows you to access the HBase NoSQL database if that's something that you're interested in using. And as I mentioned, it uses the streaming API, but makes it easier to do so. I like R Hadoop because it's modular. So the packages group similar functionality. If you're not going to use RHBase, for example, if you're not going to use HBase, for example, you don't need to load, install, or learn the RHBase package. And more to the point, you don't need to install all the prerequisites. So RHBase, for example, needs a thrift server. Why bother set that up if you're not going to use it? It is open source, so certainly there's the cost benefit there. There's very low barriers to download it and try it, but also there's the transparency of development, issue tracker, wiki, all hosted on GitHub along with the source code, and everyone's encouraged to chip in. There's also a great Google Groups discussion group. That said, it is supported. It's sponsored by Revolution Analytics. There's training and professional services available. We'll talk a little bit more later. And formal technical support is included with Revolution R Enterprise subscriptions. As an old IT buyer, I can't emphasize just how important it is to get support for software that you're relying on. What does a Hadoop cluster look like? Well, at a high level, there's a primary node or a primary server, master node, which is primarily responsible just for coordination of all the work and all the data that's in the Hadoop cluster. The processes that run on that server are called the job tracker and the name node. Jobs submitted to the cluster are broken into tasks and task attempts, and they're executed on the worker nodes or the core nodes or the slave nodes, however you want to refer to them, by the task tracker. So anything on this diagram that has an asterisk next to it, those are processes that are related to running the MapReduce jobs themselves, either coordinating them, in the case of the job tracker on the master node, or actually running the code against the data on the slave nodes in the task tracker. Usually you would have some client servers or some edge nodes, depending on how you've configured your server, to submit the jobs to the job tracker. You don't want to do too much yourself on the master node directly, since it's sort of key, so key to the operations of the cluster. And you may be writing these jobs in the language of your choice, either Java jar files or R Hadoop jobs with the RMR package that we'll show, or Hive or Pig or any of the other things. You submit that to the job tracker from your client server. Depending on the details of secondary master servers are not something we need to go into. But on the next slide, I show anything that's circled in red here. This is where the data is being either stored or managed. So the name node keeps track of where all the blocks for all the files are, and the data nodes usually only on the core nodes or the slave nodes actually store the blocks of the data. So we think about the way the distributed file system is engineered, it's actually very clever. One of the key insights to the way MapReduce systems and Hadoop are engineered is they have the key insight that often the code that you want to, in often cases the code you want to run is very small, even if the data is huge. The data may be hundreds or thousands of terabytes. It's the mythological petabyte of data out there, but the code may be very small. So what if you're able to just distribute your code around and have your code run where the data is, rather than having a very expensive bleeding edge storage device and very fast networking to bring the data to where your code is run, as was sort of the pattern in traditional enterprise architecture. In order to distribute the data around, the HDFS by default uses very large blocks and triple replication. And again, that's not just for fault tolerance. For sure, you want to be able to handle failures. If you have a large enough collection of anything, they'll fail. But also for performance, you want to give that job tracker a choice of different places to run the next work unit. And you want it to be able to find a location closest to where the data, if not on the same server where the data is to run. So if that's what the cluster looks like, how does one actually write a process to accomplish anything in MapReduce? And again, if you've seen this example, as many as some people, I apologize ahead of time, but this is really the hello world of MapReduce. And I think about when I was learning C back in the, well, I'm not going to tell you how long ago it was, but the first program you write would be a one-line command to print out hello world. This is sort of the equivalent of that for MapReduce. The idea is loaded onto our distributed file system. On the left here you see we have 4 files, very simple text files, unstructured text with some sentences in them. I say there are 4 files, so one of them's empty. That's there on purpose because, it's the real world and these things happen. What we want to do is we want to go through all of our text and count up the frequency of each word. How many times does the word Hadoop appear in all the text files in my cluster? And if this is all the content you can see, in this case it's just 1, but A is there twice. It's in the second file, it's in the 4th file, along with is. That's also there twice. So somehow we want to use Hadoop and write as little code as possible to figure this out. Well, MapReduce is called MapReduce because it has 2 main phases, mapping and reducing. Now, it's not mapping like a map of the world. It's more mapping like a nav, where you have some input and you're mapping it to some output. The output in Hadoop and the sort of lingua franca for all the components of Hadoop are key value pairs. You can think about a key value pair like a schema. If you were defining a table structure in a traditional relational database, the values would be those columns or those data elements that you're going to use in later analysis, maybe for some aggregate calculations or whatnot. And the key, it's like the primary key. What identifies this row of data? What is important? So in this case, we're counting up words. We're going to pick words to be the key. Okay, so even without writing any code, Hadoop will take the data from all the files, and it does a lot of things for you, including uncompressing data if necessary, and it even emits key value pairs. So the mapper code we're going to write is going to get a key value pair. Now, there's no meaningful key that comes along from a text file. It's something like the byte offset of where that line of text is. But the value, that's what we're going to analyze, and it's just the line of text from that file itself. What we're going to do, since we're looking at words, we're going to pick the word to be the key, and we're just going to emit a 1 for every time we see that word. It's a pretty naive way of doing it, but as you'll see, it actually works pretty well. So the first mapper, it sees, Hadoop uses MapReduce, so it emits those key val pairs. Hadoop saw it once, uses, saw it once, MapReduce saw it once. Now, if we want to write some code to take that output to count up the occurrences of those words, well, you see, we're kind of a problem because coming out of the second one, there's an is and a 1, and coming out of the 4th one, there's is and a 1. So the data that we want to count up is not only coming out of different processes. These processes may be running on different nodes, different computers. So, how are we going to be able to look across the output of all of these nodes to get the data we want to be able to count up? So for the purposes of this talk, we'll just say it does. It's like a miracle occurs. It's no miracle. We don't need to go into the technical details, but it's called the sort shuffle phase, and it's one of the things Hadoop does for you. But it underscores how important it is that you select the right key. If you want to aggregate your data by word, then you have to pick word to be your key. Whatever you pick, what Hadoop will do is it will shuffle around the output of all the mappers and stream it to disk and across the network and do whatever it needs to do. So the code you write for your reducer will have access to all the values for a given key. Here you see, for example, on the first reducer process, A was on the second and fourth before. It all went to the right, the same reducer, and both values of 1 were collected and passed into the reducer. So you can imagine how easy it would be to write a function then if it were called with that key and that collection of values to do what we want to do, which is just to add it up and get the output we want. Just to review, MapReduce has 2 main phases, the map phase and the reduce phase. The map phase is what's close to your data. That's the only code that needs to worry about the details. You emit or you generate key val pairs. You pick your key. So Hadoop does all the heavy lifting in the sort shuffle phase, collects the data you want, so you can go run your reducer. Well, what does this code actually look like in R? And I think you'll see with this example how simple it was, sort of a lot of the appeal when I first saw code like this. There's no bookkeeping function. There's no dealing with standard in, standard out. There's no looping or anything like that. You just get to focus on the functionality that you're interested in, writing that map function, writing that reduce function. So if you look at the map function here, it's getting a key and a value. I mentioned before the key is meaningless. It was like the byte offset in the file, so we don't even use it. What we do use is the lines. RMR2 has a nice feature that came in one of the later versions of the previous version. It'll actually doesn't work with just one line at a time. It takes advantage of R's knowledge of vectors. And it's always vectorized. So I think by default you get 1,000 lines of text in every time your map function is called, and that helps a lot with performance. Performance is not one of Hadoop streaming's strong suits, and this definitely helps with the performance. So what we're doing is just using a very standard R built-in function, string split, splits on a regular expression, looking for white space. So that will generate a list of words. We unlist, we unwrap that list. I tend to find lists to be sort of one level of abstraction too many. It's one of the things I'm not wild about R. But once you do that, words becomes a regular vector, and we can just use the key val. This is a supplied convenience function that comes with RMR2 to generate the key vals that, well, as we've discussed, everything needs to emit. Everything needs to return in Hadoop. And a single the single integer 1 there will be handled and exploded out as it needs. So that is all the code you had to write for your mapper. The reducer, since Hadoop's doing, again, all that heavy lifting, is even easier. It passes in the key, which was the word that we saw before, and the collection of counts. I think it's a vector in this case, so we're just able to feed it into R's sum function, and it's as simple as that. In order to call this, we just wrote a wrapper around the MapReduce function. So the MapReduce function comes with RMR2, and it handles actually bundling up the code, submitting it to the job tracker, and doing all the heavy lifting of submitting and waiting for results to return from Hadoop. We specify the input location, that's the location on the HDFS where the files are, where we want the output to be from our reducer. It will be written to the HDFS at that location, and other options like setting a text format or CSV format or any number of others that are supported right out of the box with RMR. You specify the map function by name, so map equals map, it just refers to that function up there, and reduce equals our reduce function down there. So submitting it, once your locations to point to your data and to point to your output directory, it is actually as easy as just calling the word count function that we wrote that just wraps the MapReduce function. And if you're familiar with submitting jobs to Hadoop, you would see exactly what you expect in the normal Hadoop status messages and where to go to look for the status and the map and the reduce percentage updates, and it's just a regular MapReduce jobs. What comes out of MapReduce, and by extension our word count function, this out variable, that just holds a location on the HDFS. And that's really clever actually, because it's very common to write more than one MapReduce job sort of in a series or a processing pipeline. So the output of one call to MapReduce can be the input location for the next call for MapReduce. And you can sort of build processing chains just by nesting calls to MapReduce. It's the really nice sort of syntactical sugar that's available for you. RMR2 itself has functions to interact with the HDFS, at least as far as reading and writing data. So the from.dfs function comes with RMR2. You don't even need to install RHDFS to be able to pull out your results. And lo and behold, it's just a regular data frame. And that's probably one of the things really to emphasize. There's nothing special about this code because it's Hadoop. Yes, you have to think in the paradigm of mapping and reducing, but you're writing normal R code. You're interacting with normal R objects. So in that extent, it's functional. It should be familiar, and all the functionality you expect is there, including any functionality that you're used to from Revolution R Enterprise. It's scalable, so note there was nothing in there about system configurations or anything. MapReduce and Hadoop abstract away all those system details. So the code I wrote will run on my one node. It'll run on my laptop. It'll run my one node Hadoop cluster and a VM on my laptop, or run a 1,000 node machine or cluster. Without modification. And it's really flexible. So only the mapper deals with that data directly. So if your data format changes, this happens, even with structured data. I can't tell you, last time I sort of had it with a relational database for this particular analysis project I was doing, I was relying on government data, and it was very well structured, and it was always the same every month until one day, it was about 2 years ago in the fall, they dropped a couple of fields that I was using and added 3 more fields that were kind of equivalent but not really, and what would have been 5 minutes to load it into MySQL became a whole afternoon project because I ended up having to change the schema and download another 20 years worth of data so everything fit and everything was consistent. So being able to change the data format just in one little bit of code rather than in a rigid relational structure, that really won me over that day. But of course, certainly makes sense if you have unstructured data or binary data that you may want to parse in a different way. Also, we pointed out, so the lingua franca are these key-val pairs. So as long as you're emitting key-val pairs, that's how you isolate the system from the details of the data. And also, when you're defining the key-val pair, so unlike in a relational system where you have to make this decision up front before you can even load data into the system, think about what we started with. We just had a directory full of text files. The good part about that is there's no, you have to sit through 3 weeks of meetings trying to come up with just the right schema before you can even get any data loaded. You have the responsibility, but you also have the freedom then for each analysis to determine what is the right data to pull out of these files. What is the right way to identify this? Are we counting by words today? Are we doing, market? Are we doing a customer ID? Are we doing a region? What are we doing? You can change that for each analysis, which is extremely flexible. So thinking about one of the main reasons I find people looking at these big data systems like Hadoop is because of the restrictions of traditional systems of having to structure things up front, and honestly for some organizational reasons, data silos have developed. They've developed by source of data, by data type, by source system, and even by department. Very common to walk in and find a half a dozen or a dozen or more different systems, purpose built, but really aren't able to to talk to one another, and it's really difficult to do cross-system analysis for sure. Because the problem with silos is, silos kill. Silos, kill your ability to combine across different data sources to do your analysis, and so silos kill collaboration, and silos kill business value that should be there, but by locking everything together, locking everything up separately just makes it all that harder for analysts to ask, let alone answer, some of the questions that their businesses could really use. So with that, maybe this is a good time to talk about what context you folks are planning to use these technologies together. Yanni?
Great, thank you. So our last poll, which best describes the purpose of your interest in Hadoop and R?
So Jeffrey, you just mentioned that that people are doing things that they hadn't done before. So what is meant? What do people mean when they say that with R and Hadoop you can answer questions that weren't even being asked a few years ago? What's meant by that?
Yeah, so that's a great question. So, we think about some of the excitement around these technologies, and sorry, I'm patient zero here with the flu. I had to cough. Traditional systems are out there that are very good at doing the traditional analysis, and the way they're structured, you're sort of locked into the structure. So to the extent that you want to start bringing in other data sources, either from different departments or from different data providers, or if you think about you're a retailer and you're looking at sort of the effectiveness of your marketing campaigns, well, it's not just a bookings related. It's not just a clickstream analysis, but what is the buzz on social media? To be able to have systems that are flexible, that are able to handle different data sources, very easily, you at least have a shot of asking questions, and that the data was previously locked up. Does that make sense?
It does. It does. Thanks.
Sure.
So it looks like, Jeffrey, almost 50% of our respondents are looking to develop a brand new analytics application with Hadoop and R. 17% would like to rewrite an existing analytics application. 11% want to supplement the kind of data that's in an existing application, and 22 are thinking none of the above. But it's interesting, and I think we're finding the same thing, that the combination of Hadoop and R, because of the new kinds of data that are being available through Hadoop, we're seeing a lot of net new kinds of applications, specifically in the area of marketing analytics, customer intelligence, and new fraud applications that are being written because of this R-Hadoop combination, just opening up so many doors for them.
Excellent, and we're going to talk about some of those examples when we get to the real client examples next. So the first example I'd like to talk about, so we're working with a financial services client, and all of these examples are projects that ThinkBig has worked with Revolution on as part of our, usually as part of our Quick Start offering, which we'll talk about at the end. So we had a financial services client, and they had built a model using a legacy system to estimate the credit risk of their account holders. Obviously, very, very important, and it ran fine. They were able to run it, in a batch mode, over the weekend or whatnot to score all the accounts to see, which ones might be at risk. The challenge was they wanted to move from running it, every now and then to running it much more frequently, ideally nightly, and they simply couldn't scale up their analysis with their existing hardware, and I'll be honest, and their licensing constraints. It's easy to go out and buy a bunch of servers, but if you can't afford to put the software you need to run on each one, it doesn't do you any good. So what we did is, leaving the legacy system in place, we're able to extract the model coefficients. As I recall, it was a logistic regression. So we just got the coefficients that came out of the legacy system. We exported them from that system and just wrote them as a text file to the Hadoop distributed file system. So once it was there, it was available to all the nodes, and we wrote some R code that basically used those coefficients in a logistic regression. I actually brought some code because that's the kind of guy I am to show you how to do this, to run the scores every night. So RMR has some functionality in it that makes even some of the advanced techniques that we talk about in Hadoop, very easily. Generally, when you're processing data, you do it, through the mapper, emitting the key vals to the sort shuffle, going to the reducer. But for small data sets, especially, like model coefficients, or even, sort of lookup tables, converting airport codes to latitude and longitude, or airport names, or zip codes to Latin long, or IP addresses to zip codes, or whatnot. For smaller data samples like that, it can be very helpful to side load it. It's like bringing in all your friends to the stage door. So you can sideload the data, and Hadoop has a distributed cache and a way to send files around outside of the HDFS for this purpose. And it's not too hard to do, but RMR too makes it sort of extremely simple. In fact, you may have noticed when we submitted our word count job, all I did is I said that the map function is this function called map, and the reduce function I want you to use is this function called reduce. I never did anything special like exporting that or writing those to disk. RMR2 actually did all that for me when I called the MapReduce job. So what it does by default is it looks in your local R environment and serializes to disk just using the standard save functionality in R. It's a thing that comes up when it asks you if you want to save your workspace. So it serializes it to disk and puts it in the streaming job jar and distributes it around to all the processes on all your nodes in the cluster. So if you have, for example here, I'm loading in that CSV file that we've saved on a special location on the HDFS. I just load it in as a data frame. By convention, I put it in all upper caps because that's how I was taught to program, global data names. But there's nothing special about that. That and any other variables I have in memory when I call the MapReduce function are automatically loaded and made available to all my code running on all the nodes. So people who are maybe more comfortable with R's inner workings than I, might be comfortable force-feeding coefficients into a GLM object. I'm sort of not, so I wrote my own scoring algorithm. But it was as simple as this: sending in the coefficients, sending the data, and then running the logistic regression, the logistic equation to compute the probabilities of default. It was as simple as that. It was able to scale linearly on commodity hardware, just the way you'd expect. So that was a great success to be able to rapidly increase their scoring capability for their accounts. So we worked with another very large company, definitely a company you've all heard of, and let's just say they're risk aware. But in order to serve their clients, they have to maintain a large web presence, and they're able to reach fairly deep into their enterprise systems. So they have a very, very sharp group of engineers and data scientists whose job is to try to minimize the risk of this public web exposure. And they actually instrumented up their network with some packet sniffers and captured their network traffic in PCAP. So PCAP files, if you're familiar with TCP dump in Unix, it'll write these PCAP files that are binary format of the network traffic it sees as it's sniffing. There are a number of libraries in Hadoop to help you parse PCAP files. So I used one of them here and came up with a really interesting solution, working with Revolution and another one of our partners. It's sort of a combination of algorithms on the full sniffed data set to try to estimate what a normal network session looks like, and built a training phase using a couple of these algorithms to figure out what normal traffic looks like, and again built a model and wrote the results to the HDFS similarly to the previous example, but in this case it was our Hadoop code, it was RMR code that was generating that was doing the fitting and generated the model coefficients. And then a separate job, very similar to the last example, that would read in the baseline results, would read in the baseline model, and then crank through all the incoming network traffic as it came along to help look for anomalies. So those were two examples where we used R Hadoop, particularly ARM-R2, for writing MapReduce jobs sort of at the low level. Writing mappers and writing reducers, the sort of code that people have been doing for a long time in Java. I want to talk for a couple minutes about a technology that we're using more and more, and honestly, in our opinion, it's going to be the killer app for Hadoop. It's called Hive. It looks like a relational database. It's definitely not a relational database, as we'll see. But it's very familiar to people who know relational databases because it provides a SQL-like query language. It's very approachable as a result. But what it does is it takes that language, it's called the Hive query languages, and it compiles, optimizes, and executes these scripts, these queries, as MapReduce jobs, and handles all the interaction back and forth with the Hadoop cluster. So if you look at what Hive looks like, you can think of it as sitting on top of Hadoop with our, all the details are still there in our Hadoop cluster from, down below. And there are different ways to interact with it. You can connect to the CLI. It has a command line interface, just like you might expect a relational database to. It also has a web browser interface. I'm not a real fan of those things in any database. But also, a thrift server, there are JDBC and ODBC interfaces into Hive. And that's that's actually the first mechanism we're going to talk about. But again, remember, it's making MapReduce jobs. It's just doing them for you and allowing you to get started with a language that may be more familiar to you as a data analyst. And this is actually the way that one of the clients that we worked on together had taken their first step into Hadoop. So it was a market research company, and they had really a very good mature code base in R to conduct some mission critical analysis. They were doing a lot of segmentation, a lot of predictive analytics based on that. But they were reaching the limits of their legacy database infrastructure, and they had decided to move to Hadoop, but they couldn't afford and didn't want to take the risk of a big bang project to try to rewrite everything to keep the the functionality that they needed while switching to a new platform. So they weren't looking to rewrite everything as MapReduce jobs and whatnot, at least not initially, not in a big bang way. So it's a stopgap solution. One of our technology partners actually had done some of this work to switch the ODBC connections that had previously gone to a legacy relational database over to Hive. And in so doing, allowed really minimal recoding of the existing system. So everything still worked the way it should, and they were able to load all the new data they were getting into Hadoop. And it was a nice way for them to start. And as an old IT guy, I can definitely appreciate another benefit of this is you're allowed to have parallel testing of two systems. The old system's still up and running, at least loading as much data as you can, while you can run the same analysis on the new system, at least the subset that's available in the old system. And it was just a really nice solution. I just thought I'd show you, for those of you who are familiar, using the RJDBC or the RODBC library, just how easy that can be. This all should look very familiar to you, except until you get to the very last line and you see the details of the query. That is definitely Hive query language. That's looking at doing a lateral view over to a table generated out of a complex, I think it's an array of strings in the subordinates field there in our sample table. But again, the other big difference there is, this doesn't have millisecond response or second level response like people are used to from a relational database. There is really Hadoop down there. It is still batch oriented. It takes 20 or 30 seconds to tie its shoes. So this isn't the be all and end all, but it's a great place to get started. And this reminds me of so the last example I was going to show you. This was a client we worked with, has a really bright analyst team, worked with a really sharp analyst who had a segmentation model based on a sizable database of web visitors, but they'd signed a partnership agreement with a new data provider that brought an order of magnitude or more data into the mix, and they were looking for a way to scale up. So since a lot of their preliminary work to get the data in the right shape to do some modeling. Since a lot of those operations were very relational and looked very database-like, we actually used a series of MapReduce jobs. I think almost all of them were actually Hive queries to do some of that pre-processing, and then write the final output to HDFS. And then one of the really neat features in the new version, I think it's 6.1 of Revolution R Enterprise, is you can actually read data directly off of the HDFS into Revolution R Enterprise. And you can do that either text files or Hive output or pig output or whatever you have, or the XDF format itself. And once it's in R, this is sort of the paradigm I see a lot. Big data in, small data out. If you have a petabyte of data, you probably don't have a petabyte of insight to go along with it. You do tend to winnow down the bulk of the data until it's at a manageable size to take into tools that you may be more comfortable with, especially if you want to do iterative or interactive or exploratory analysis. We've covered a few ways that R and Hadoop can work together. I mentioned the first one. In the new version of Revolution Enterprise R, you can read and write the files directly to the HDFS. There are other alternatives if you are using R with MapReduce jobs in particular. There are open source packages out there like Repay and Segway, and they have slightly different focuses each. Oracle has a solution now. And I mentioned Hive. So when we're talking about Hadoop MapReduce jobs and talked about how Hadoop streaming opens up MapReduce to non-Java languages, anything that can handle standard in and standard out. Well, Hive itself can interact with external scripts using streaming also. And there's a new project out there that I'm looking forward to learning more about called RHive that uses RServe to connect the two. So we have some events coming up. We're having some public courses that I'm teaching with Revolution's help in the next couple of days, and there's an Eventbrite link there. The first one's the day before Strata. So Strata starts on Tuesday the 26th, and we're holding our class, and also actually we're having a Hive class that same day, but we're holding getting started with our Hadoop one-day class at Revolution's headquarters on Monday the 25th, and then next month we'll have one here at my home base in Boston, and more on the way, and that link will be updated. And of course we offer together a quick start program that includes the training and some on-site consulting assistance to get initial use case, up and running, and also some Revolution Enterprise R for Hadoop licenses and support. So with that, I'd like to really thank you for your attention, and hopefully we have some time for some questions.
Great, thank you, Jeffrey. There's a bunch of questions, lots of questions, so we'll try and get through as many as we can, and our support team will follow up with the remaining questions. So our first question comes from Kevin. The word count example shows the sum of sums. So mathematically, I understand that we are getting reliable answers. But I worry about the reliability of other statistics as we reduce them. Can you address the mathematical aspects of this concern?
Sure. So I think one of the challenges you have when you're looking to program statistical analyses especially in MapReduce, the MapReduce framework, you want to distribute the work across the clusters as evenly as you can, across the nodes in the cluster as evenly as you can to maximize sort of the computational efficiency. But right there, you're segmenting. You're bucketizing the data. So you're forcing it. In this example, it's trivial anyway, but it's not an issue because what you're doing is aggregation, and you're aggregating across all the occurrences of a word. And there's no ambiguity. Either it's word A, or either it's word B, or it's not. The challenge I think comes when you're doing some analysis that requires visibility across different key values. Or different different values of the key, so different keys. is. If you wanted to study, 3 words at once, well, you may not have visibility to that because Hadoop has done its job distributing that around. There's also some other techniques we didn't talk about. There are other ways to reduce the bulk of the data in flight using combiners. So you would never use combiners if your reducer needed sort of the visibility across the full distribution of the data, but it works great for extrema if you're looking for mins and maxes, or aggregations if you're looking for sums. Even means can be tricky. You tend to emit not just the mean but the count, so you could roll it up later and do a weighted mean. So yeah, I mean, it's a good question. It's something you need to worry about when you're shifting into a MapReduce, or when you're shifting into any new programming paradigm.
Thank you. This question comes from Scott. Do you have to use RMR MapReduce to do R analytics in Hadoop? Jeffrey? I'm sorry, did you hear the question? Hello?
We might have lost him
I
to a
think
call
so. I think so.
there. Jan, no, you don't. RMR isn't the only way to work with analytics in Hadoop. We can talk more about that. If people reach out to Revolution or Think Big, we can provide more details about the ways that R can be used in and around Hadoop environments. I noticed there was another question that's kind of related about whether or not you need to use RMR in Hadoop, or whether or not Revolution R Enterprise capabilities can be used beside Hadoop in addition to running some R analytics in Hadoop. And the answer is yes. There's a number of ways, depending on the use case and the requirements that you have as an organization, that we would collectively recommend deploying your R and Hadoop environment.
Can you hear me now? I can hear you now.
Okay.
There you go, Jeffrey. Yep.
Hey, sorry about that. Thank you, Verizon, wherever you are. So I actually had a quicker answer. It was like, so I like RMR because it does all the overhead, but streaming deals with standard in, standard out. And if you don't mind writing loops to deal with standard in, standard out, you can have at it, and you can just write jobs, using R script natively without any help. And then you're more like the way most of the Python guys work, and that's fine. That's what you want to do.
Great, thank you. We have time for probably about 3 more questions. This question comes from Francois. When is big data or data big enough to warrant Hadoop?
Wow, great question. Great question. What is big data? So we could just talk about that for a whole hour, right? I think the most succinct, meaningful answer I can give you is, if the data is too big for you to use in your current environment, and especially if you're anticipating, different, the different structures, different sources, or sort of accelerating velocity, give Hadoop a look. There, it's not perfect. It's not for every use case. It is distinctly batch-oriented. There are a lot of interesting projects coming out now, both related to Hadoop and not. I'm thinking of things like Impala from Cloudera. I'm thinking about Storm and Kafka for doing more real-time analytics. Not batch-oriented, but interacting well with Hadoop. I'd say Hadoop addresses sort of 2 things. One is being able to flatten the cost curve, because it is all based on commodity hardware. It doesn't mean bad or cheap hardware, but it's all general purpose computing facilities, and there's a lot now, an increasing amount of talent out there and experience to help. So it's becoming a less and less sort of risky or exotic a solution.
Thank you. We're just about out of time. I have a couple quick questions. Paul loves the word count example, and he's wondering if the code is available.
The word count example must be available in multiple places, but I will take that as an action to publish a nice clean example, maybe with those couple of slides.
Great. Thank you, Paul. Thank you, Jeffrey. So this last question comes from Roman. He writes, Jeffrey, you also wrote a wonderful RMR example about airline data. Do you plan to update your example? Do you plan to update your example code to RMR 2?
I sure do, and I haven't, and I apologize, and I will.
Okay. Great. I think with that, we're all out of time. Thank you, everyone, thank you, Jeffrey, for a wonderful presentation. Thank you, Kathleen. Thank you, everyone, for joining today. As I mentioned earlier, the webinar is being recorded and will be available on our website within 48 hours. I'll send an email out to all the registrants when that webinar is available, recording is available. Also want to let everyone know that our next webinar is on Thursday, February 14th, where Joseph Rickert is presenting Introduction to R for Data Mining. And you can register for that online. And with that, I'd just like to thank everybody and hope you have a great day.
Thanks, everyone.
Thanks, Jeffrey. Bye-bye.